All right, guys, so last section is going to be on section 7.3, logarithmic functions. What you need to know, the most important part of this whole lesson, is these two formulas. A log, or what we've talked about before, was an exponential. Y equals b raised to the x power. All right, what we're going to have now is a log. These two statements, y equals b to the x, and the log of y base b equals x. Mathematically, they're the two things are the same. So what we're going to have to be able to do is go back and forth between the two. All right, at any point, pause your video so you can keep up or get ahead of me. All right, so I'm going to give you an exponential. You're going to write it as a log. So I'm going to give you y equals b to the x. That's what we're given. 25 equals 5 to the second power. What we're going to do is we're going to write it as the log of y base b equals x. So I'm just going to pick out my pieces. So I'm going to say the log of my y value, 25, base b, which is my 5, equals my x value of 2. So mathematically, log of 25 base 5 equals 2 is the same as 25 equals 5 squared. Just got to be able to go back and forth between them. All right, so number 2, 729 equals 3 to the 6th power. 729 equals 3 to the 6th. So this is my y equals b to the x. I want the log of y base b equals x. So I'm going to say the log of my y value, 729, base my b value, base 3, equals my x value. The log of 729 base 3 equals 6. That's the idea. Given an exponential, we need to be able to write it as a log. So I give you this time b to the x equals y, just written in a different form. Doesn't matter. Log of y base b equals x. I'm going to say the log of my y value, 1/8, base my b value, 1/2, equals 3. So the log of 1/8 base 1/2 equals 3. And the last one, b to the x equals y. The log of y base b equals x. The log of 1 base 10 equals 0. All right, what you need to understand, and you may see this, log base 10, okay, is the same for this problem as just the log of 1, right? When you work these, a log base 10 is the same as just a log. If it doesn't have a base, it's automatically a base 10. So these two are the same. Log base 10 and log are the same. All right, now we'll go the other direction. Log of 128 base 2 equals 7. The log of y base b equals x. Y equals b to the x. So I'm going to say my y value, which is 128, equals my b value, which is 2, raised to the 7th. All right, so we've got to be able to go both directions. And once you see these, once you can write these two underneath, write the one that you're given with the variables, and then write the one you want, and it's pretty easy. Log of 1/4 base 4 equals a -1. So that's my log of y base b equals x. I'm going to say y -1 equals, sorry, not -1, let me back up. My y value, which is 1/4, equals my b value 4 to the -1. And we know this is true because this negative exponent would put the 4 in my denominator, so I'm good. All right, so all of these, when you write it as an exponential, if you do that math, 2 raised to the 7th power, you better get 128. All right, now I'm going to ask you to sketch. I'm not going to ask you to graph. I'm going to ask you to sketch this. Okay. What we're going to have to find this time is a vertical asymptote. Okay, we're going to get it from the picture. So what I'm going to do I'm going to open up Desmos. All right, and this is acceptable for this problem. All right, let me pull this back. We're going to graph the log of x. So I'm going to have, a bunch of extra stuff. I went to graphing calculator. Graphing calculator. Here we go. All right, so I'm going to type in y equals, and I'm going to go down here to my keyboard, go to my functions, and I want my miscellaneous log of x. So I didn't have a base. So I'm going to type it in. All right. Now looking at this, we are going to have a vertical asymptote instead of a horizontal. We're going to have a vertical line. And if I look at this, right here, right here it looks like I have my vertical asymptote. Right? That's my vertical line that my graph crosses. It doesn't look like it goes over. So what I'm going to say is I have a vertical asymptote for this one right here, which is the equation x equals 0. That's my vertical asymptote because it looks like my graph, and go back to here, curves towards it. The next thing I'm going to look for is that y-intercept. This one has a y-intercept at the point 1, 0. So I'm going to go back to my table, my graph. I'm going to put a point at 1, 0. All right, looking okay. Now, all right, looking at the shape, it looks like, and all I want you to do is we're going to draw this graph and make it look something like this. And this, for now, is y equals the log of x. It has an x-intercept at the point 1, 0. So what we're going to look for is we're going to look for vertical asymptotes. This vertical asymptote's x equals 0. We're going to look for an x-intercept at the point 1, 0. And then we're just going to make a basic sketch. I'm not going to ask you to find the other points. This is going to be enough. That's how I want you to graph y equals the log of x. We're going to plug into Desmos. We're going to find out where that vertical asymptote is. We're going to find out where my x-intercept is, and I'm going to make a basic looking picture. All right, let's do one more. Y equals the log of x minus 1 base 2. All right, y equals the log of x minus 1 base 2. So let's go back over here. Let's get rid of this one. All right, I'm going to go to my keyboard, my functions, miscellaneous, and this time I'm going to do log base. So I want the log of 2, base 2 of x minus 1. And I'm going to get that. All right, looking at this one, let me zoom out a little bit. All right. As I follow this graph, see if I can get it to work. It looks like as I just go along, if it's going to let me, I'll do it over here, maybe it'll make it a little better. All right, this point. Let's see if I can find. There we go. All right, as I go, gosh, it doesn't like me doing this. Okay, it looks like to me, I could draw a vertical line, and I'll do it down here just to see it, at x equals 1. All right, so I just typed in the line x equals 1. Yeah, that looks like my vertical asymptote. So I'm going to say, go back to here. X equals 1 is going to be my vertical asymptote. So I'm going to draw that line over here at x equals 1. All right, going back to my graph now. My x-intercept looks like it's the point 2, 0. So I'm going to put a point at 2, 0. Kind of getting an idea what's going on. All right, that looks good. Now I'm going to do this. And I will accept this as y equals the log of x minus 1 base 2. My x-intercept was the 0.20. And the idea of this is I want you to be able to graph these in the calculator right now. In the future, we may get into doing better graphs, but we need to be able to plug these in the calculator and know how to plug them into the calculator. Understand my vertical asymptote that my graph goes towards but doesn't cross. All right, that's the idea that I want you to get across today, is being able to graph these in a calculator, finding intercepts, finding asymptotes, and like 1 through 6, being able to convert between the two. That's the idea of today's lesson. All right, so there's an assignment in the classroom that we need to finish.